So, hello everyone. I'm Professor Neetu Mehta. Today, we are going to learn about design of cylinder in subject called IC engine component design. So, design of cylinder is segregated in three portions. In three portions are: one, we are going to learn about what is function, working, velocity aspect of a cylinder. Then we will move on to design of the cylinder, and ultimately we will take one of the case study for the cylinder. So, before getting into specifications, we should know what is the working of cylinder. As I have mentioned, and I will get into that also. Working of cylinder goes like this. Cylinder helps piston to guide in such a way that it can have reciprocating motion, as well as at the same time it retains, or you can say it will get each and every time your fuel in such an amount that in each and every stroke. So after that, we are going to learn about materialistic aspect depending on its function and manufacturing process. What kind of manufacturing process we are going to have for our cylinder, and ultimately we are going to learn about what kind of casting of cylinder we will have. So, what is the function and what is the working of our cylinder? So, working of our cylinder is like this. It is provided to guide piston and retain working of our working fluid. Or you can say it provides some passage to guide our piston to have reciprocating motion, and as well as at the same time it will provide retaining each and every stroke without losing any amount of fuel while working in a suction stroke. So this is basically its function. Now, depending on its function, we should know about the materialistic aspect of our cylinder. So basically, cylinder is a structural component. It is not a moving component. So it provides support to our piston, cylinder, or you can say IC engine assembly. So our cylinder is more of a structural component. It comes under compressive types of load. So in previous chapter, while working with design consideration, we have come across a topic called casting. In casting, we have learned about that. Casting is a process which provides good amount of strength against compression rather than tension. So here a cylinder will come across compression rather than any kind of tension. So in case of our cylinder, material will be cast iron or cast steel. What represented by this cast iron? So the cylinder block, or you can say cylinder head, will made from iron which is casted in some mold. Why it is so? Because it comes under excessive amount of compressive load. Why is that so? Because it is a structural component rather than any moving kinematic unit. After that, what is its working condition? We know the function as well as material, but we should also know about this working condition. What kind of condition it will come across while working with our IC engine. So we should know also about our working condition. So while working, it comes under, now like in previous introductory chapter, I have told you about, it comes under excessive amount of direct stress as well as excessive amount of thermal stress. Now direct stress, as I have told you in that topic, that it will comes under directly that fuel blast. So it stress will generate circumference of our cylinder and ultimately try to bend up or open up our cylinder head. And after that, we should come across high amount of thermal stress due to excessive amount of heat transfer, or you can say heat concentration. So main byproduct, you can say byproduct, or you can say it is a main drawback or criteria to design is thermal concentration. So we should know about, or we should provide any arrangement to get that heat out of our cylinder block. Why is that so? Because in each and every stroke, some amount of thermal stress will occur at each and every part of our cylinder lining. So we should arrange that cylinder lining in such a way that the heat transfer process will intended to increase the heat transfer transfer rate of our cylinder. So you know that in single cylinder type of engine, we are using, or you can say we are going to provide an artificial cooling system. In that, fins, okay, fins, when it has a low power engine, or you can say single cylinder engine, we are providing fins as an arrangement, or you can say design of a cylinder block. We are creating in such a way that it can easily have a heat transfer just depending on its geometry. Second type of cooling system is to provide cooling jacket around our cylinder. Now, if I am providing cooling jacket, and you know that our cylinder comes across immense amount of stress as well as temperature, so it will always tend to roughen its surface inside. So after some amount of life cycle, you have to change that cylinder block. And it is, you know that it is very much tedious process, or you can say economically impractical process. So in many cases, when our cylinder liner, or you can say engine, is very heavy, we are provided with cylinder liner inside our cylinder block. What is the cylinder liner? Cylinder liner is an arrangement which directly in contact with our piston as well as our fuel. So ultimately, when our cylinder goes out of its alignment, or you can say it deforms, or we have to change the cylinder liner rather than whole cylinder block. Clear? So in or you can say in car engine of automobile or four-wheeler car, we are using this kind of engine arrangement in which we are going to provide cylinder liner rather than making a cylinder block from a single piece casting. So there are multiple types of liner which we have here. Because why we have to provide this liner? First of all, we should know about that. This liner we are going to provide just because of it has increased excessive amount of temperature due to high power engine. So we are going to use this liner in only high power engine. So there are two types of liners which we have. One is dry liner, another is wet liner. So what is dry liner and what is wet liner? Also in GTU, this question is always occurs. What is dry liner and what is wet liner? So dry liner, in a case of dry liner, this is dry liner, in which you can see this portion, or you can say this blue color portion is a cylinder liner, and the pink color portion is water jackets, in which this liner will be directly not or indirectly in contact with cylinder jacket. That is called dry liner. And when jackets, or you can say liner is directly in contact with water jacket, or you can say water vessel, that is called wet liner. Where our engine is very heavy compared to any lower type of engine, or heat generation in our engine is very much excessive, then in that case we are going to provide this kind of water jacket arrangement which is called a wet liner. And when we come across a lower power, or you can say lower concentration of heat occurs, then we can use a dry liner. So from this arrangement, we can know, or we will get this how we are going to use dry liner and when we are going to use wet liner. In case of wet liner, our engine power will be very much higher. In case of dry liner, our engine power will be very much lower. Please look at this arrangement. This is passage provided to water flow, and this is liner. So when our component, or you can say liner deforms, all you have to change is this portion only. You don't have to change the outer cassette, the outer jacket. Here, okay. So cylinder block, we are not going to change whole cylinder block. We are going to change rather than this liner. Okay. I hope you will get each and every aspect of our cylinder and cylinder liner. In next video, we are going to discuss about design criteria of our cylinder, and we will going to focus on design consideration, manufacturing consideration, and metallurgical consideration of our cylinder. So goodbye for now. Thank you so much. Hello everyone, I am Professor Nero Mehta. Today we are going to discuss about design consideration for a cylinder. In the last lecture, we have discussed about different aspect, or you can say theoretical aspect of our cylinder. In this lecture, we are going to discuss about basic consideration, basic component and basic geometry of our cylinder to be designed. Which kind of or what kind of part we are going to design in our cylinder. But before that, let's have a quick recap about our fundas of cylinder. What is function of our cylinder? Cylinder function is to provide guidance and to retain our fuel in each and every time. So it provides guidance to our piston and retains fluid or fuel in each and every stroke. What is its material and manufacturing process? So its material is cast iron and manufacturing process is casting. Why casting? Because cylinder block is more of a structural component rather than a moving component. So when it comes to structural component, it becomes under compressive stress more rather than its tensile stress. So it will show a good amount of resistance against that. And after that, we have come across a working condition. We have discussed about different working conditions of our cylinder. Cylinder has to work under immense amount of thermal stress as well as direct stress. So depending on its thermal stress, we have designed a cooling system which is artificial cooling system. In a low power engine, or you can say single cylinder engine, we have used field as a cooling element, or you can say geometrical change in our cooling element. And for multi-cylinder engine, or you can say high power engine, we have used a different arrangement which is called a jacket arrangement or artificial cooling system. So in this video and this lecture, we are going to discuss about design consideration and design concept of our cylinder. So cylinder is basically divided into 4 different parts while designing it. Here, because it has come across a different types of stress depending on certain forces. So what kind of forces it will come across? So there are 2 main forces. One is pressure generated by our gas, or you can say gas pressure. Force generated by gas pressure. How this gas pressure increases? Gas pressure increases due to a blast in fuel. It will increase pressure inside our cavity, and ultimately it will create immense amount of force, whether it is circumferential force or in head or magnetic force on our piston cylinder head assembly. So depending on that, there are 4 vital components, or you can say vital geometry of our cylinder we are going to design. First is we are going to design or decide thickness of our cylinder wall. So what could be the thickness of our cylinder wall? Because this cylinder wall will going to determine our engine's security and working of our engine efficiently without losing any type of force or without losing any type of efficiency. So first of all, we are going to design is thickness of cylinder. After that, we are going to decide what the goal of our cylinder and length of our cylinder. How we are going to determine all of this? The thickness of the cylinder, or the wall thickness of the cylinder, we are going to determine depending on stress generated on our cylinder wall. And how this stress generation? So before getting into the stress, we should know about what exactly stress is. Simple stress. What is stress? Stress is a reverse mechanism of body. If any kind of force, if I'm taking this duster, in normal condition, or you can say in isolation condition, it doesn't appear or it doesn't come under any kind of stress. But at the same time, if I'm putting any type of force, this is kind of a compressive force. It will exert a restriction, or you can say reverse mechanism, or you can say an inherent force to oppose this external force, and this inherent force inside this duster will create a stress. So stress is nothing but a reverse mechanism body against any external force, and this stress will ultimately lead to deformation of our component, because when this stress will cross that elastic limit, or you can say plastic deformation limit, it will create any deformation in our component. Why this stress is required? Why this stress is to be determined? Because you know that while working condition, if our component shows any kind of deformation or any kind of change in shape, it will directly affect the efficiency of our component. So we have to design a component which shows a robust condition and which should not change its geometry in each and every condition and in each and every stroke. So first we are going to design thickness of our cylinder, and then we are going to determine bore and length of cylinder. This bore and length of cylinder will be determined depending on the gas pressure generated due to our power of, or you can say, fuel burning of an engine. Ultimately, this will provide which is what is optimum length and what is optimum bore of our cylinder. So after deciding this cylinder, you can also determine directly or indirectly diameter or outer diameter of piston. So this bore also gives you outer diameter of piston, and as well as it also provides you swept volume of our cylinder piston assembly. Then we are going to design flange and studs. What is this flange and stud? Because cylinder block is a different, or you can say, two-part of assembly. In on the cylinder piston block, we are going to provide cylinder head, and the cylinder head will be fixed by the stud, and the portion which is fixed at stud is called flange. So here, this flange and stud will comes under immense tensile strength, tensile force due to direct stress acting on a cylinder head. Here, when this blast occurs in our cylinder, as I have discussed in previous chapters in introduction, when this blast occurs, it will try to open it up in circumferential direction as well as in longitudinal direction. Like if I am considering it as a cylinder cavity, when this blast occurs in the cylinder cavity, it will create circumferential stress as well as longitudinal stress. This circumferential stress directly affects the wall thickness of the cylinder, and longitudinal stress directly affect this cylinder head. This cylinder head is fastened by the stud as well as flange provided around our piston cylinder assembly, and the stud will directly come across immense tensile stress. So we have to design the stud and flange in such a way that we will provide resistance against this tensile stress. And ultimately, cylinder head over this also comes under direct stress, so we have to design the cylinder head and cylinder head thickness. So our first design aspect in this design of cylinder is thickness of cylinder wall. So how you are going to design this thickness of cylinder wall? So in design concept, we are going to use a similar algorithm in each and every time. So for that, first of all, you have to determine what kind of forces acting upon our body and what is reaction in terms of stress will provide by our body. So first of all, we are going to determine what kind of forces acting on our body. So one force, or you can say force acting, and stress produced, which is also called reaction of our body. So what are the forces, or which kind of forces acting on our body? So there are two types of forces acting on our body. One is force is produced by gas pressure. What is this gas pressure? After end of compression stroke, blast occurs, and this blast will create immense amount of gas inside that cavity, and that cavity will create force around the circumference as well as on head of our cylinder. So ultimately this gas pressure force, and then after that, you do that side thrust. You know that the piston will go to and fro motion. But if I am not restricting the piston with guidance of cylinder, it will provide a kind of a circulatory motion. So each and every stroke, piston will exert a side thrust over our cylinder wall assembly. So this cylinder wall will come across two kinds of stresses. One is gas pressure force and another is piston side thrust. So we are going to design our cylinder wall thickness depending on these two forces. These two forces are acting on the cylinder. As I have given an example of the luster, till you are not applying any kind of force, your component will not show any kind of stresses against that. So you have to consider this force as an acting force and this stress as a reaction of your component. So ultimately, this reaction will be in terms of two types of stresses. One is longitudinal stress and another is circumferential stress. As I have told you in the case of this bottle, when the blast occurs inside this cavity, there are two types of stress occur. One is longitudinal, which try to open it up in vertical direction, and circumferential stress, which try to open it up in circumferential, or you can say more of a vertical direction. Horizontal direction. So there are two types of stress will occur, and we are going to design this component, or we are going to design the cylinder in this two direction. When it will come across the vertical direction, we are going to design this cross section area. So consider this: when stress will when orientation of force is in vertical direction, then we have to design perpendicular section of our component. And if it is in horizontal direction, then we have to design this perpendicular wall of our component. Here in next video, we are going to consider this two aspect of geometry, with design with geometry, and we will discuss about our design derivation to determine thickness of the cylinder wall. Thank you so much.